Happy day for my dear students and viewers. This is Nagarajan working as an assistant professor in the Department of Electrical and Electronics Engineering in MIM School of Engineering, Trichy, accredited by NAC, approved by AICT New Delhi, affiliated to Anna University, Chennai. So today we are going to discuss about the non-metallic electrode. It is also called as micropipette. Okay, in the previous slide, in the previous video, we discussed about the metallic electrode. Since the electrode is composed of, that is the enclosures is made up of metals, and that is why it is named as metallic electrode. And the whole electrode is made up of metals. Okay, and that is used to measure the potential of a single cell. And this is also going to measure, this non-metallic electrode is going to measure the electrode that is the potential of a single cell. The size of the diameter of that metallic type, the tip of the metallic type electrode is from 5 microns to 0.5 microns. Okay, so now you will have a small glance about this non-metallic microelectrode. Okay, this electrode is uses non-metallic material to measure the potential of a single cell. Okay, non-metallic material of a potential of a single cell. Okay, so the tip of this non-metallic is made up of, it consists of a glass, okay, with a diameter of 1 micrometer. Okay, 1 micrometer. This micropipette is filled with an electrolyte. Usually it is potassium chloride. Okay, usually it is a potassium chloride which is compatible with the cellular fluid. Okay, which is compatible with the cellular fluid. Okay, a thin flexible metal wire. Okay, a thin flexible metal wire from chloride silver. Okay, from chloride silver, stainless steel. Okay, this one stainless steel or tungsten. Okay, is inserted into the stem of the micropipette. Okay, is inserted into the stem of the micropipette. Here I will show that one is inserted into the stem of the micropipette. Okay, this is the micropipette, and the fraction between the wire and the stem of the micropipette and the cellulars and the fluid surface tension hold the micropipette on the wire. The other end of the metal, okay, the other end of the metal, that is this one, the other end of the metal, this A, okay, the other end of the metal is mounted on a rigid support and the other is free to the end. Okay, so here also we have another electrode that is called as reference electrode. Okay, here also we will be having an electrode called as reference electrode. And now to get the electrode potential, okay, to get the electrode potential, we are supposed to add 4 electrode values, 4 potentials. Okay, that is first one is EA. EA is nothing but potential between the metal wire and electrolyte filled. Okay, between the metal wire and the electrolyte. So the potential voltage generated is as follows. Okay, what are the voltage potential? We have to be summed. That is, EA is the potential voltage between the metal wire and electrolyte filled. Okay, and EB is the potential between reference electrode and extracellular fluid. EB is the EB is the potential between the reference electrode and extracellular fluid. EC is the variable cell potential. EC is the variable cell potential, and ED is the potential at the tip. Okay, ED is the potential at the tip due to electrolyte present inside the pipette and the cell. Okay, inside the pipette and the cell. Now we are going to discuss about the equivalent circuit of this non-metallic. Okay, so let us come to the equivalent circuit of the glass micro pipette type, that is non-metallic electrode, microelectrode, and here this RA. Okay, this RA is this RMA. Okay, and the CMA will be there, and this is nothing but the impedance. Okay, impedance of the electrode and electrolyte interference. Okay, electrode and electrolyte interference. This one, this is the impedance, and RT is the resistance. RT is the resistance of the electrode and the resistance of electrolyte filling the tip of the micropipette. Okay, RT is the electrolyte resistance filling the tip of the micropipette, and Ri. Okay, this Ri will be the resistance inside the cell. Okay, resistance inside the cell, and here we have another it is also can be considered. Okay, this small portion will also be considered as the extra, that is electrolyte outside the cell. Okay, resistance of the electrolyte outside the cell, and here again this CMB and RMB will be considered as the impedance. Okay, constitute the impedance of the reference electrode, constitute the impedance of the reference electrodes, since it is the terminal B. Okay, and CD, this CD is the distributed capacitance, okay, existing between the fluid in the pipe, and the extracellular fluid. So these are the important things to be, parameters to be considered in this micropipette type, that is non-metallic. Okay, so that's all with the today's class. We will see the surface electrode in the next class. Thank you.